But what I'm going to talk to you a little bit about is another set of challenges that we've seen and potentially opportunities to fix them as well in containerized storage. So first, just a little bit about myself. I'm Evan Powell. So I've helped found a number of enterprise software companies, including Nexenta, which is a ZFS-based Solaris kernel company, based storage company, what we used to call software-defined storage. I guess we still do. More recently, a company called StackStorm that was acquired about a year ago. And these days, what I'm doing is helping a company called Cloudbyte that started a project called OpenEBS. And so what I would say is, while I'll certainly take questions, I would really appreciate questions as well to myself and to the engineering team online in the open. It's an open source project. Have at it. So as you see things that you wonder, what the heck is Evan talking about, please feel free to dive in. Also, I won't be doing a demo, but there is a nice Vagrant image there. You can grab an entire Kubernetes cluster with OpenEBS underneath it and some workloads and hammer it yourself. Having said that, we are at 0.2, getting to 0.3 soon. So while it's fun to demo and it does some interesting stuff, please don't run real production workloads on it quite yet. So just quickly, I've been spending the last couple of years helping folks like Netflix kind of at this layer of the cloud. Let's see if this pointer. And really working with folks who are running massively more dynamic, scalable, container-based, typically, environments. And that is with the help of StackStorm, my prior company. And I'm going to go from a slide at this kind of high level to the internals of how we're chunking data and using metadata here in a second, again, in a whistle-stop type fashion. But the thing I would say as a relatively experienced, or at least old, entrepreneur who has worked with a lot of environments, and I heard somebody asking the question about City, it is a wave that none of us are going to resist. Containerization is here. It's accelerating. It's imperfect. It's unsafe in a lot of ways. And it's an unstoppable force, the likes of which I have really never seen. So I'm going to talk to you a little bit about how you go from the level that we were at just a second ago. Really, by the way, I should maybe stop and just say it's a little bit daunting to follow James, not only because he's brilliant, but if you think of those of us who have lived in the open source world, we really owe our existence to folks like James in the Linux community itself. So it's a real honor to be up here. But I'm going to be at a little bit higher level. I'm going to be talking a little bit about how are these, so the future is, as Gibson and others have said, the future is unevenly distributed. It's already here, but it's unevenly distributed. How are folks actually doing persistence and other workloads on containers today? How are they providing some pretty incredible experiences to their developers? The first point I would say is that the stateless environment is pretty well known. And this is kind of what we were getting at before, let's say, VMware and others showed up and redefined what we maybe were imagining software-defined would be, which is you write some code, you have some human-readable, machine-executable instructions as to how you want the infrastructure to behave. You check that in, and it works. The infrastructure truly dances to the tune of the developer and, in these cases, these days, the microservices they're coding. I really think it's happening. I think it's a big reason why this community is mind-blowingly big now, the Kubernetes community. And the productivity we see, I helped start the event-driven automation meetup here in the Valley. You know, when we got sort of introduced a meetup, but then we went to Facebook and they made us sign NDAs, which was sort of an interesting moment. Like, wait a minute, we want to put this on the web. But you know, the productivity they're bragging about here, I think, is fairly true. You're talking a few orders of magnitude or more in terms of the amount of systems they can manage and the productivity of their DevOps engineers than a typical enterprise bank, as an example. I mean, they claim that FBAR handles something like 10 billion events a week, and they have only 3 people in network ops. It's a little bit of marketing, but gives you an idea of the productivity that can be achieved if you really wire together your environment fully. Unfortunately, setting aside what's wrong with the kernel and permissions and security today, stateful workloads also have an orchestration issue today, and most approaches have entailed taking your cattle, taking your containers that are supposed to be somewhat impermanent, and more or less wiring them into your underlying storage, one way or the other. Currently, it's more on the pod level. It used to be more down at the container level. Either way, kind of broke the whole approach. To our desired state of state, there are a variety of bad puns in this PowerPoint, if you care to pay attention to that. Our desired state of state, of course, is to make this user's experience the same, whether they're running stateful or stateless. And you do see it. We have Pearson as a big user for Stackstorm. They're using it, or Netflix, which was using Stackstorm, is using it around Cassandra. There are ways to get there, but we think it ought to be done more at the storage layer. And really, my call to you guys is, go to OpenEBS, go to our GitHub, check it out, and give us input. But now I'm going to go from this kind of high level into what have we built so far? What are we building? But again, the desired state and the desired, what we're really doing is focusing on this persona of the DevOps engineer, making them able to check into their code, a little bit of YAML, add on to that pod definition, some information about storage, and just make it so. A little bit about a high level, how we're doing it, some of the definitions of what we wanted to get done. One of the things is, when you look at, our fundamental assumption is that it's not enough to take a storage controller and cram it on a container and say, it looks good, like we've containerized storage. Instead, what we're saying is, if we're serving microservices, if we're serving highly automated DevOps environments, we ought to have a storage controller that itself is composed of microservices that can be upgraded and managed in a DevOps-friendly way. So we basically said, yes, we have a good multi-million-dollar business in the legacy software-defined storage space. Let's write the whole thing anew in Go. Let's do it in a containerized way. Let's do it in a microservices way as well. And so what it ends up looking like, this is a simplified view, but this is your kind of what a Kubernetes environment looks like, where you have N masters, you have minions, and they talk a lot about pods, which are a definition of what is needed to actually run the compute. We do something quite similar, but at the storage layer. And this is showing the two bifurcated, but as you might imagine in practice, all of this is running on containers adjacent to the hosts, typically. So in other words, this piece, which is effectively a storage scheduler, is some brains that we think needs to exist. And so what I'm going to talk a little bit about here in a second is what do we do about metadata, both down at the container level, when we're actually writing data to disk, but also sort of this level of metadata as well, which keeps track of which containers have access to which underlying storage. So again, we are doing a lot of work with a lot of help from some initial users so that, again, we've really refactored the storage controller itself. So you're starting to see things like replication, and I'll show this again, caching algorithms and so forth themselves as microservices. And this is more detailed than maybe you ever wanted to know about that. But again, check it out if you're interested on our GitHub. But you see, we're really partitioning this. And we have the notion of a front-end container and a back-end container, and our Maya is the underlying orchestration that helps to figure it all out. So let me stop for a second. What should you be able to do? What could you do? You grab the Vagrant image right now and throw the workload on there. You can literally go through and shoot the controller itself and see the product continue to work, even though it's on 0.2, 0.3. So what you should be able to begin to treat the storage controller as an ephemeral object itself. That's some of the what we think the persona really wants to see. So a little more about Maya, which again is a storage orchestration. We have here, again, as you might imagine, it's a little bit similar to etcd at the Kubernetes level. We've got to track state, so we have some persistence of state that is being tracked up in our controller, up in our orchestrator. And again, we've partitioned this out a little bit. Now, this may be the mother of all eye charts. This is the first time we've given this deck or a talk like this. We've done meetups, and obviously this will be posted. But this gets into how we're starting to chunk the data, and how we're using that to get away from what we view as a frequent bottleneck around metadata. And I have a kind of a simple drawing on this, so you don't have to actually eye chart all the way through this, but it gives you kind of an overview of what we're doing and some of the key differentiations as well. So while on the one hand it's about enabling this DevOps persona to treat storage in a normal way, on the other hand, we're also looking at, hey, we're refactoring this. We're going to have thousands, tens of thousands, hundreds of thousands of effectively block-based storage containers scaling out. How do you do this in a way that the metadata does not crush you? Chunking. So in our case, we are chunking. And then writing down to disk and eventually, or obviously to flash or to persistent memory. And in our case, it doesn't really matter what the underlying file system is. And this is the same idea, but this is supposed to be the before. So if you're dealing with a global metadata at a system level, obviously that is going to scale more quickly than if you're really chunking and having smaller pieces of metadata and allowing some of the metadata down at the local file system to handle it. So to you as an application, if you were an application or a microservice on one of these hosts, you see OpenEBS as effectively local storage to you. And the storage and the orchestration should be able to handle the rest of it. And again, we should achieve some real reduction in the amount of metadata. This is probably, again, more detail than you want to know, but it's not exactly super innovative in the sense that we're looking up where the chunks are, and that's one way that we're keeping track of where everything is. Some of this is based on some pre-existing open source as well. So again, if you check it out, you'll see that this is not all brand new code. Some of this is leveraging other code that's out there in the Kubernetes community. And I have a variety of other slides that go through the sheer scope of what we are doing. And you know, you see, I mean, things like the tight integration into Kubernetes, but also EBS. I mean, one of the things that's happened in the storage world in the last, let's say, 10 years or so since I've been working, or 15 years in it, is obviously AWS. And there's this giant sucking sound for a lot of workloads. Well, something that we're doing and that a company I work with on the proprietary side called Cloudian is doing is saying, hey, why don't we leverage the APIs they give us so that you, as a storage team serving your development team, you don't have to tell them, well, yeah, okay, you like S3 and you're writing apps expecting that to be there, or you like EBS for your containers, you're expecting that to be there. It's going to be a little bit different when you run on the enterprise quality storage that we have here. Instead of saying that, why don't you say, well, actually, we're EBS compatible, we're S3 compatible, it should just freaking work. And so that is, we really baked in trying to behave like EBS. It's not enough to have API compatibility, as you know, if you're not manageable in the way that EBS is. And we're not fully there yet. The proprietary company I mentioned is called Cloudian. They're probably closer, but even there, they're not behaving fully like Amazon is from an S3 standpoint. But again, we're trying to enable this boost in productivity by really fitting into the pipelines of DevOps environments. Yeah. So you can orchestrate us like you can orchestrate your underlying Kubernetes environment, as I've mentioned. Part of what you can get from this is starting to be able to do rolling upgrades. I mean, we were talking about rebalancing Ceph, and I can tell you rolling upgrades is one of those terms that is used in storage quite a bit and is rarely achieved. And part of it is just the difficulty inherent. But part of it too is the architectures of these systems tend to be fairly mature or old, not partitioned into lots of microservices that themselves can be easily upgraded. Or, I mean, do you really upgrade a container? Not exactly. The way it's done is a little bit different than that, right? You get the new version of that particular microservice, you instantiate it, it works, right? And so enabling that kind of functionality inside a storage system itself is a little bit different. But we also think it's quite necessary for these new environments. And it's the kind of thing we're seeing in my past life at StackStorm in environments that are actually achieving storage on containers for containers as well. Yeah. Again, a bit of a list. So what I would say is this is where we're at, somewhere over here, right? We're coming out with 0.3. It's not an accident that we came out with a pretty cool demo of this, a Vagrant type image that you can grab and play with and start to get some familiarity with it today. We are X months away from getting to 1.0. I got involved at the beginning of the year, end of last year. The commercial company behind this is called CloudByte, so we're backed by people like Fidelity, who's also been a customer of mine over the years, and Nexus, which is a large fund. Myself and other operators are involved. We have plenty of time to enable OpenEBS to grow into a real community, and we're at those sort of baby steps today. This group, and why I was really happy to be invited here, you can beat us up now or on the community, and hopefully you see at least how audacious it is to say, hey, we're not just going to serve containers and those workloads, we're going to actually embrace a microservices approach to building controllers and enable you to begin to treat the containers that are delivering, in this case, stateful workloads and storage for your containers in the same way that you treat your containers. So that's what we're about at OpenEBS. Again, I'm Evan Powell, and look forward to hopefully collaborating with a few of you guys. Yeah?
Great talk, thank you. Questions for Evan?
What are you talking about?
Go ahead, yeah.
Could you share your thoughts on the containerization efforts around Ceph and how that relates to EBS, OpenEBS?
Yes. So yeah, there's at least, so Ceph is not quite ubiquitous, but widely deployed. I think it's Quantum is supporting an effort called Rook to basically put a core set around Ceph and deploy it in containers. And I think that there's some very smart people working on that project. There's a proprietary company called Portworx, who similarly has, let's say, storage DNA, and has just raised a bunch of money from some very good VCs. And so there is an acknowledgement that probably to solve this problem, you have to containerize the controllers themselves, one way or the other. In the case of Portworx, and definitely ourselves, we think you need to rewrite it. It's not clear whether the Ceph Rook community will go there or not. Right now, it's more like let's wrap it's a simplification, but let's make it play nice with Kubernetes in the containerized environment and get it running there, which is an important project. But it's a maybe slightly less audacious and/or more wise incremental approach.
So you think there's enough justification to start from scratch and from a microservices mindset, building out a scale-out storage system?
We certainly think so.
Okay.
Exactly.
Any other questions for Evan? Okay, very good. Thanks again.
Thank you.
Appreciate